Hello everyone, so today we're going to go over section 6.3, multiplying proper fractions. We'll begin with a warm-up, just looking at the shaded regions below here, and what fraction is represented by each one. So in the first case, we can see that there are 20 squares, and 12 of them are shaded in. So this would be 12 out of 20. Right next to it, in the second example, we have 10 rectangles, 6 of which are shaded in. And of course, these rectangles are of equal size, so this would be 6 over 10. And finally, in the last case, the shaded region is 3 spaces out of the 5 that are there, so this would be 3 over 5. Notice that these 3 fractions are actually equal to each other. The second and third fractions are simplified version of the first one. And the last fraction, 3 over 5, is the simplest form. So since we are multiplying proper fractions today, being able to reduce fractions will be very useful. So look at how to do this without diagrams. So suppose we have something like 15 over 30. One possibility is to divide both the numerator and the denominator by 15, since both of these numbers are divisible by 15. And in this case, we'll be left with 15 divided by 15, which is 1, and 30 divided by 15, which is 2. However, it's not always easy to find the greatest common denominator, so sometimes, greatest common factor. So sometimes what we can do instead is to divide by smaller common factor. So that in this case, let's say we divide both of these numbers by 3. So 15 divided by 3 is 5, and 30 divided by 3 is 10. And then from there, we can divide by 5 in both the numerator as well as the denominator, and we'll get 1/2 just the same. So we can always use an in-between fractions to get to the simplest form. Okay. And in the second example here, we can simply divide by, let's say, 3, for example. So 12 divided by 3 will give us 4. And 36 divided by 3 will give us 12. And from there, we can divide both the numerator and the denominator by 4. And we will get 1/3. Okay. So next, we have a couple different fractions. So in the first case, we have on the left-hand side here, this is 1/2. And if we have a piece of paper which is equal to 1, if we fold it the way that we did and shade in the left-hand side as we did here, we get 1/2. Likewise, if we have the same piece of paper and we fold it in the other direction into thirds, this top rectangle will be equal to 1/3. And the idea here is if we combine the shaded regions, one that is done vertically and the second that's done horizontally, this common area of the two, and that is to say the area that has been shaded twice, is actually 1/6, or 1/6 of the original one piece of paper. So we have 1/2 times 1/3 is equal to 1/6. Since effectively what we did was we took 1/2 and we sliced that 1/2 into 3 equal pieces, and we get 1/6. Okay, so we can also use this for other fractions as well. We have 7/8 times 5/6. So we can fold a piece of paper or this grid into 8 columns and 6 rows. So we're going to shade in 7 out of the 8 columns, like so, and 5 out of 6 rows. And if we count the number of rectangles that were shaded in twice, we will get 7 times 5, which is 35 rectangles that were shaded twice. And the total number of rectangles in this piece of paper or in this grid would be 48. So in other words, 7 over 8 times 5 over 6 would be equal to 35 over 48. And in this case, there's no common factors, so we can just leave the fraction as 35 over 48. Okay. Second example, very similar idea. So we have 4 over 9. As such, we're going to shade in 4 columns out of the 9 columns that are here. Something that looks like this. And out of the 8 rows, we'll shade in 6 of them. So something that looks like this. So once again, we're looking at the number of rectangles that are shaded twice. So as we can see, 4 columns and 6 rows were shaded in twice, which makes a total of 24 of these rectangles that were shaded in twice. And then out of a total of 9 columns times 8 rows, which is 72 total, because 9 times 8 is 72. So what we have here then is 4 over 9 times 6 over 8 is going to be equal to 24 over 72. Notice that both the numerator and the denominator are divisible by 24. And this fraction is actually equal to 1/3. Okay. So, to multiply proper fractions without models, what we can do is simply multiply the numerators together and then multiply the denominators together. So in this case, we have 4 over 5 times 3 over 4. So 4 times 3, of course, is 12. And 5 times 4 is 20. And from there, we can reduce by dividing by 4. And we'll get 3 over 5. Okay. Likewise, in the second example, 3 times 5 is 15. And 5 times 6, of course, is 30. And as we have worked with before, both of these are divisible by 15. And so we get 1 over 2. Okay. So of course, now that we have seen multiplying proper fraction with diagrams, we can look at this diagram and figure out what happened. So in this case, it's just a previous example that we saw, which is it's actually not one of the previous examples we saw. This is 3 over 5. And the second fraction here is 4 over 5. And if we count the rectangles that are shaded twice, we have 12 of them out of 25 total rectangles. So this will be 12 over 25. Okay. So to summarize the steps of multiplying proper fractions without using models or diagrams, there are 3 steps. The first step is to multiply the numerators together. Second step is to then multiply the denominators. And if possible, the third step would be to reduce the fraction to lowest terms. All right, so let's look at some fractions here. Now, it's going to introduce another step to make some of these questions easier, and that is we can actually reduce the fractions before we multiply. So as you can see here, we have an 8 in the numerator and a 6 in the denominator. So what we can do is we can actually divide both of these numbers by 2 ahead of time. So this will give us 4 and 3. Likewise, we also have 5 and 15. One is a numerator, one is a denominator, so we can go ahead and simplify that ahead of time. So we can divide by 5 here, so we get 1 and 3. So from there, once we multiply these two fractions together, we will have just 4 over 9. Of course, it is still possible to multiply first and then reduce. So in that case, we'll get 8 times 5, which is 40, over 15 times 6, which is 90. And you can see here, or we can see here that both of these are divisible by 10, so we still get 4 over 9, doing the question this way as well. Now, it's probably a bit easier to reduce first, just to keep the number small. So in this case, we have a 3 in the numerator and a 9 in the denominator. So once again, we can divide both of these by 3. So this is 1 and 3. And from there, we can multiply these together. 1 times 2 is 2, and 5 times 3 is 15. Right. Some cases, it makes the questions quite a bit simpler. So in this case, notice that we have a couple of 5s that can be reduced. And also, 4 and 6 are both divisible by 2, and this will give us 2 and 3. So the product is actually just 2 over 3. Okay. In the next example, both 4 and 12 are divisible by 4. And also 7 and 21 are both divisible by 7. So in this case, this will give us 1 and 3. So once again, when we get to the step where we multiply the numerators together, 1 times 1 is 1. And then 3 times 3, the denominators multiplied together, will give us 9. So this is 1 over 9. And since we reduce before multiplying, we don't have to reduce afterwards in general, unless we didn't reduce to lowest term or completely in the first place. Okay, so one more of such examples. We have here 27 and 36. If we look at the numerator from the first fraction and the denominator for the second one, they are both divisible by 9, so this will give us 3 and 4. For the second pair of numerator and denominator, we have 35 and 49. Those are both divisible by 7, so this will give us 5 and 7. And from there, 3 times 5 gives us 15, and 7 times 4 is 28. Okay. Okay, so let's look at a quick word question here. 4/5 of a school class have at least one sibling. 1/3 of them walk to school. What fraction of the class is made of a student with at least one sibling and who walk to school? So this would be 4 over 5 times 1 over 3. And that will simply be 4 over 15, seeing as how there's no reducing that could be done beforehand. So and the units here will be of the class. So the last part of today's lesson is about estimating fraction multiplication. So what we can do is, again, estimate the product here by deciding if the fraction is close to 0, 1/2 of 1, and, and then estimate the product. So in the first case, we have 3 over 5 times 1 over 9, so this would be close to 1/2, and 1 over 9 is close to 0, so the product would be closer to 0 than to, say, let's say, a half. So likewise, the second one, we have 4 over 9 times 3 over 7. So both of these are pretty close to 1/2. And this will give us a estimate of a quarter. I should not use an equal sign here. Sorry about that. We should use instead kind of a symbol for estimates. Right? We estimated what each fraction is, and then we estimated the product afterwards. In the last case, 9 over 11 is closer to 1, and 7 out of 13 is close to 1/2. So this fraction will be closer to 1/2 than to, let's say, 1 or 0. Okay. And then what we can do afterwards, I'm just going to do one of these examples here. We can instead, of course, multiply these. So in the first case, if we were to actually multiply, this would be 3 over 45, which is equal to 1 over 15. And if we look at 1 over 15, let's say on a calculator, for example, it is certainly closer to 0 than it is to, say, let's say 1/2 or a quarter or so forth. Okay. So that's the idea. In the second case, 4 over 9 times 3 over 7. The decimal representation of that would have been 0.19, which is pretty close to a quarter, and that is to say 0.25. And that's the idea here. We're just estimating the products without actually having to calculate them in each case. So we saw today how to multiply proper fractions using a diagram and also without a diagram. And then finally, we looked briefly at estimating product using 0, 1/2, and 1. And that's it for today, so thank you for listening.